Okay, so we're going to try a function question, and it says below is a graph of this particular function here, 3 plus 2x minus x squared, and it's drawn in the domain already from -2 to 4. So they've done all that work for you, and they've actually drawn the graph. There it is there. And the questions are as follows. Use the graph to write down the roots of the equation. Okay, when you're asked to find roots, you're looking to see where the function comes through the x-axis. Where does it break through? And you'll see it breaks through it there and there. Just like the roots of a plant. Where does it come through the ground? So the roots in this particular question are, well, the first one is there. It's -1. And the second one is over there. It's 3. So 1 and 3. Sorry, -1 and 3. The second question, it says find the values of x for which fx equals 3. fx equals 3. Well, what was fx again? fx was up here, remember. It's 3 plus 2x minus x squared. So we write that 3 plus 2x minus x squared, and they want to know when is that equal to 3. So we put it equal to 3. Okay, that's the first step. Now bring everything onto the same side. So bring this 3 over here, and you'll end up with 3 plus 2x minus x squared minus 3 equals 0. And you see that that 3 and that 3 can cancel. And you're just left with 2x minus x squared equals 0. Now at this point you factorize. So some people, you could do this in either two ways. You could get it in the order of, you'd see a quadratic in where the x squared is first. Like that. And you'd find what a is, what b is, what c is. So in this case, a is -1, b is 2, and c is 0. And you'd sub it into the minus b formula. Minus b plus or minus the square root of b squared minus 4ac all over 2a. Or a much easier way would be to factorize using the take out what's common method. So we have, the equation is this, 2x minus x squared equals 0. What's in common? Well, x is in common, so take x out and then have brackets. What would x have to multiply to give you 2x? It would need to multiply by 2. And what would x need to multiply to give you minus x squared? It would need to multiply by minus x. And now when you have that done, just put each part, so the bit that's outside the bracket, equal to 0. There's your first solution. And the part that's inside the bracket, equal to 0. And then get the number onto the one side. So x is equal to 2. There's your two solutions. Now I'm sure if you did the minus b way, so this bit over here, you would end up with the same answers of 0 and 2. But this way over here is just quicker. Okay, part 3. It says find the value of f 2.5. Okay, when it's written like that, and the number is actually in the brackets, that's where you actually just sub that number in to the function. So normally you'd see an x in there, but in this case you see 2.5, and that's the hint that you're going to sub in 2.5 for x. So let's remind ourselves of what the function is. It's 3 plus 2x minus x squared. So you write that down. This is part 3. 3 plus 2x minus x squared. And you're going to sub in 2.5, or 2.5, I'm going to call it, minus 2.5 squared. And what do you get? You get 3 plus 5 minus 2.5 squared is 5.25, I think. I think so, yep. So in that case, you end up with 3 to 8, take away another 2.75, I think. I'm not doing this with a calculator now. You might double check with a calculator there to make sure that that's right. Part 4, the maximum value of fx. So that's where you look at the graph and you see where is the graph at its highest point, the maximum, and it's here. And where is that? Where is that? It's at 1. Okay, straight down, read off the x-axis, you get 1. So the answer to 4 is 1. If I was asked for the, well, I am actually, in the next question I'm asked for the coordinates of the maximum point. So this is where you need the coordinates. So this is where you not only read off the x-axis, but you also read off the y-axis. So what's that point? It's 1, 4. So part 5, the answer is 1, 4. So the maximum value, which is what we did in part 4, that's where you just look at the x-axis. And the maximum point or coordinate, that's where you read off both. And the very last question, question 6, says the equation of the axis of symmetry of the curve. That's probably the hardest one, but it's really quite straightforward. So the axis of symmetry means where would the line be drawn that would cut the shape completely in half so that it could fold over on itself. Okay, so that's what it means to be symmetrical. It means to be perfectly equal on both halves of a shape. So the axis is the line that you would need to draw to create that equality. So if you look at the shape, you see it is the type of shape where it is equal if you drew a line somewhere, right? Where would you need to draw the line for you to be able to fold the shape over on top of itself? So you can see if I drew a line straight down here, along there, I could fold this left onto this right and it would be perfectly symmetrical. There's nowhere else I could draw a line that would create that symmetry. Like if I drew a line here, if I said that was the axis of symmetry and I folded it over along that line, it wouldn't work. They wouldn't be equal. If I drew a line along here, it wouldn't work. They wouldn't fold over on top of each other. It wouldn't be symmetrical. The only place is if I drew the line along there. And to find the equation of that line, you simply just say x is equal to, and whatever point it passes through x on that line, so in this case 1. So that's part 6. It's much easier than what it looks, the equation of the axis of symmetry of the curve.